Bismillahirrahmanirrahim. Exploring Marketing Research. Chapter number 11, Part 1, that is Experimental Research. After studying this chapter and this part, you should be able to create an experimental independent variable through a valid experimental manipulation of its value, understand and minimize the systematic experimental error. The nature of experiments. Most students are familiar with scientific experiments from studying physical sciences like physics and chemistry. The term experiment typically conjures up an image of a chemist surrounded by bubbling test tubes and Bunsen burners. The nature of experiments. Behavioral and physical scientists have used experimentation for longer than have marketing researchers. Nevertheless, both social scientists and physical scientists use experiments for much the same purpose. Experiments are widely used in causal research designs. Experimental research allows a researcher to control the research situation so that causal relationships among variables may be evaluated. The marketing experimenter manipulates one or more independent variables and holds constant all other possible independent variables while observing effects on dependent variables. Events may be controlled in an experiment to a degree not possible in a survey. The nature of experiment. Independent variables are expected to determine the outcomes of interest. In an experiment, they are controlled by researcher through manipulations. Dependent variables are the outcomes of interest to the researcher and the decision makers. A simple example would be thinking about how changes in price would influence sales. Price would be an independent variable and sales would be a dependent variable. The brand would be an experimental independent variable and 100-point rating scales indicating liking would be the important dependent variable. Experiment. A research investigation in which conditions are controlled, one independent variable is manipulated, sometimes more than one. Its effect on a dependent variable is measured to test a hypothesis. There's a very simple description about the experiment. I repeat it again for you people. A research investigation in which conditions are controlled, one independent variable is manipulated, sometimes more than one. Its effect on a dependent variable is measured to test a hypothesis. Basic issues of experimental design. Experimental design is a major research topic. In fact, there are courses and books devoted only to that topic. Here, an introduction into experimental design is provided. So, in this chapter only, we are going to briefly talk about experimental design, and I will give you the description about the experimental design. Basic issues of experimental design. A student should be able to design and implement basic experimental design with this introduction. Fortunately, most experimental designs in marketing are relatively simple. Basic issues of experimental design. Experimental designs involve no less than 4 important design elements. These issues include manipulation of independent variables, selection and measurement of the dependent variables, selection and assignment of experimental subjects, control over unnecessary variables. I will explain one by one these 4 issues. The experimenter has some degree of control over the independent variable. The variable is independent because its value can be manipulated by the experimenter to whatever he or she wishes it to be. Manipulation of independent variables. The thing that makes independent variables special in experimentation is that the researcher actually creates his or her values. This is how the researcher manipulates and therefore controls independent variables. Experimental independent variables are hypothesized to be causal influences. Manipulation of independent variable. Therefore, experiments are very appropriate in causal design. The experimenter controls independent variable. The variable's value can be manipulated by experimenters to whatever they wish it to be. Experimental treatment. An experimental treatment is the term referring to the way an experimental variable is manipulated. For example, a researcher can manipulate the brand with an experimental treatment, assigning consumer to taste either Pepsi or Coke, for example. Thus, there are two levels or values of the brand variable. Experimental treatment. Here is another example with which you can understand easily what is experimental treatment. A medical researcher may manipulate an experimental variable by testing some subjects with one drug and the other subjects with a separate drug. In the retail atmosphere experiment, the color treatment can be either blue or orange, and the lighting treatment can be either bright or soft lights. So, experimental variables often involve treatment with more than two levels. For instance, prices of $1.29, $1.69, and $1.99 might represent treatment in a pricing experiment examining how price affects sales. Manipulation of independent variables. Manipulation of independent variables can be described with the help of classificatory versus continuous variables, experimental and control groups, treatment levels, more than one independent variable. I will explain one by one all these manipulations. Manipulation of independent variable. Experimental variables can not only be described as independent variables, but they also can be described as a categorical variable because they take on a value to represent some classifiable or qualitative aspect. Color, for example, is either orange or blue. Advertising copy style is another example of a categorical or classificatory variable that might be manipulated in an experiment. Manipulation of independent variable. In other situations, an independent variable may truly be a continuous variable. When this is the case, the researcher must select appropriate levels of that variable as experimental treatments. For example, lighting can actually be varied over any level from no brightness onward. Before conducting the experiment, the researcher decides on levels that would be relevant to study. The levels should be noticeably different and realistic. Experimental and control group. In perhaps the simplest experiment, an independent variable is manipulated over two treatment levels resulting in two groups, an experimental group and a control group. An experimental group is one in which an experimental treatment is administered, while a control group is one in which no experimental treatment is administered. For example, consider an experiment studying how advertising affects sales. In the experimental group, the advertising budget may be set at $200,000. In the control condition, advertising may remain at zero or may not change from its current level. By holding conditions constant in control group, the researcher controls for potential sources of error in the experiment. Sales, the dependent variable in the two treatment groups, are compared at the end of the experiment to determine whether the level of advertising, the independent variable, had any effect. Note that this simple experiment can only produce a main effect. Several experimental treatment levels. The advertising sales experiment with one experimental and one control group may not tell the advertiser everything he or she wishes to know. If the advertiser wishes to understand the functional nature of the relation between sales and advertising at several treatment levels, Additional experimental groups with advertising expenditures of $250,000, $500,000, and $1 million might be studied. Several experimental treatment levels. This experiment may still involve a control variable. By analyzing more groups, each with a different treatment level, a more precise result may be obtained than in the simple experimental group. Control group experiment is described above. This design can also produce only a main effect. More than one independent variable. An experiment can also be made more complicated by including the effect of another experimental variable. Our extended example involving retail atmosphere would typify a still relatively simple two-variable experiment. Since there are two variables, each with two different levels, four experimental groups are obtained. Often the term cell is used to refer to a treatment combination within an experiment. Dependent variable. Its value is expected to be dependent on the experimenter's manipulation. Criterion are standard by which the results are judged. Selection and measurement of dependent variable. Selecting dependent variable is crucial in experimental design unless the dependent variables are relevant and truly represent an outcome of interest. The experiment will not be useful. Sometimes the logical dependent variable is fairly obvious. Selection and measurement of dependent variable. If researchers introduce a new cinnamon, pink, grapefruit tea mix in a test market, sales volume is most likely to be a key dependent variable. However, if researchers are experimenting with different forms of advertising copy appeals, defining the dependent variable may be more difficult. For example, measures of advertising awareness, recall, changes in brand preference, or sales might be possible dependent variables. Selection and measurement of dependent variable. In the retail atmosphere example, retail patronage was the key dependent variable. However, other potential dependent variables might include perceived product quality, excitement, or price perceptions. Selecting and assignment of test units. Test units are the subjects or entities whose responses to the experiment treatment are measured or observed. Individual consumers, employees, organizational units, sales territories, market segments, brands, stores, or other entities may be the test units. People are the most common test units in most marketing and consumer behavior experiments. In our retail atmospheric example, individual consumers are the test units. Sample selection and random sampling errors. As in other forms of marketing research, random sampling errors and sample selection errors may occur in experimentation. For example, experiments sometimes go every even when a geographic area is specifically chosen for a particular investigation. A case in point was the experimental testing of a new lubricant for outboard motors for Dow Chemical Company. The lubricant was tested in Florida. Florida was chosen because researchers thought the hot, muggy climate would provide the most demanding test. In Florida, the lubricant was a success. However, the story was quite different when the product was sold in Michigan. Although the lubricant sold well and worked well during the summer, the following spring Dow discovered the oil had congealed, allowing the outboard motors idle all winter to rust. The rusting problem never came to light in Florida, where the motors were in year-round use. Thus, sample selection error occurs because of flaws in procedures used to assign experimental test units. Florida conditions made the experiment irrelevant in Michigan. Systematic or non-sampling error. Systematic or non-sampling error may occur if the sampling units in an experimental cell are somehow different than the units in another cell, and this difference affects the dependent variable. For example, suppose some professors are interested in testing the effect providing snacks during exam on student scores. The experimental variable is snacks manipulated over three levels. Number one, fruit, two, cookies, and three, chocolates. The test units in this case are the individual students. When the professors conduct the experiment for convenience, they decide to give all of the 8 a.m. classes chocolate for a snack. All of the 1 p.m. classes get fruit, and all of the 7 p.m. classes get cookies. While this type of procedure is often followed, if our taste and digestive systems react differently to different foods at different times of the day, systematic error is introduced into the experiment. Furthermore, because the night classes contain students who are older on average, the professors may reach the conclusion that the students perform better when they eat cookies, when it may really be due to the fact that the students who are older perform better no matter what they are fed. Thank you. That's all for part 1.